Okay, so we're continuing with chapter 15. So last class we talked about the reaction quotient, the Q, how that relates to K. All right, so now we're going to start talking about, well, how do I find K if I'm not given the equilibrium concentrations? So remember, we can find K if we're given the concentrations. So for example, when we did the picture with the little dots, and we could just plug in the numbers, or for example, this one, when we had the equilibrium concentrations, we could just plug it in. So now we want to talk about, what if I don't have those equilibrium concentrations? How do I go about finding Kc? Okay, so the best way for me to explain this to you is to work a problem. So we're going to work a problem together so you can see this. Now I'm going to introduce something in this problem called an ICE table. An ICE table is really, really important. You're going to do ICE tables in this chapter, you're going to do ICE tables in the next chapter. So if you don't know how to do the ICE table, you need to reach out to me. Remember, I've got my live office hours. Go on the bulletin board. You can get in that Google Doc, and if I'm changing my hours, it's right underneath that. Per day, if my office hours change any. Okay, and I always update that the day before. So you should always know when I'm live for you to ask me questions, and then you could always email me or put a question in that document and I'll answer it later whenever I check it, okay? Most of the time I'm glancing at it, but I might be making a lecture and then I'm not glancing at it, okay? So, let's talk about how to do this. So let's read the problem first. It says H2 gas and I2 gas were added to a heated container. H2's initial concentration was 0.01 and I2's initial concentration was 0.008. At equilibrium, I2's concentration is 0.0056. Determine Kc. All right, and then I have the equation. So what am I looking for? I'm looking for the Kc, okay? What did they give me in the problem? They gave me the H2, and remember, anytime we write this, I want you to write what it's for. Is it equilibrium, a final, initial? It's the initial. 0.01 molar. What else? I2 initial at 0.008 molar. And then also I2 equilibrium. So this one's equilibrium, initial. All right, so I have the initial for H2, the initial for I2, and I2's equilibrium, and I want the Kc. So I'm looking for the Kc, I need to be able to write out what my Kc equation is, right? So let's work on that. So Kc should be products over reactants. They're all gases, so they all count. So Hi squared H2 times I2. Okay. So if we want to find the Kc, the numbers that we plug in here to do the math have to be equilibrium concentrations. So do I know anything about HI's concentration? Nope, I don't know anything about HI, period. Do I know H2? I know H2's initial. This number can't go here. The only numbers that could go in my Kc's are equilibrium. In my Q's, it can be initials. But if it's the equilibrium constant, it has to be equilibrium concentrations. So this 0.01 can't go here. And then do I know I2's equilibrium? Yeah, I know that number. So I only know one number. So that means I'm going to have to find the other ones. And this is where an ICE table comes into play. So what I like to do is I like to rewrite my equation, just so that it's easier for me to see what I've got going on. So H2 gas plus I2 gas goes to 2HI gas. Okay? Then we're going to write an ICE table. ICE. I is going to stand for initial. C stands for change. E stands for equilibrium. So ICE table, ICE. All right, now we're gonna plug in the information that I know already. Okay, so what did they tell me? I have my KC. H2's initial was 0.01. So initially H2 is 0.01. All right, I2 initially was 0.008. This is 0.008. All right, now we know this guy. So for this, it's 0.0056. Now, we want to write it here, but we're also going to kind of write it a little bit below the line. You'll see in a second why I'm going to do that. All right, so that's everything I know. And then I'm a KC, which we'll deal with later, because I can't do anything with this until I know the equilibrium numbers. Okay, now let's think about this. So I've got the initial of H2, the initial of I2. What would be the initial of HI? So before I even start my reaction, before I do anything, how much product would I have? None. Because when I start, I only have reactants. I don't have any product when I start. Okay? Because at the initial, I haven't started the reaction yet. All right, now let's do the change. Okay? The change is going to talk about once the reaction gets going, what should happen. So what should happen is I should lose reactants and make product. So if my reactants are going to lose, these are going to be negatives. And I'm going to make products. So this would be a positive. So I lose reactants, I make products. So negatives, positives. Now, I need to know by how much. So this is where the stoichiometry comes into play. This is a 1 and this is a 1. So since this is a 1, here, this would be like a 1x, or just x. So we're going to lose this, because we lose it because it's a reactant, by 1x. We're going to lose him because he's a reactant, and there's a 1 here, so he's a negative x. We're going to lose him by 1x. He's a product, so we're going to make him, there's a 2, so this is going to be 2x. Okay? So negatives for reactants, positives for products, and then the number, how many x, depends on the stoichiometry, a 2, a 1, or a 1. All right, now we kind of draw lines, and we do this math. We kind of like rewrite this. So the equilibrium would be 0.01 minus x. So it will reach equilibrium when after the initial has changed by this much. So we just kind of copy it down. Now we're going to copy this one down, and then copy this one down. Because this is 0, so it's 0 plus 2x, which is just 2x. Now, we're trying to do our KC, okay? So we're trying to find the KC. So the KC would be this number, and this number. Those are my equilibrium concentrations. This is equilibrium from H2, equilibrium from I2, equilibrium for HI. That's the stuff we're going to plug into these brackets here. But I don't want to plug in an x because I'm trying to solve for KC. I want to plug in actual numbers. This is where this guy is really important. In my problem, it told me that this was the equilibrium concentration for I2. So what that means is that this is equal to this. So I know that 0.00560 is equal to 0.008 minus x. So now I can find my x. Once I solve my x, now I can plug that x into this guy, this guy, this guy, and actually have numbers. So it's going to seem a little long, but if you learn how to do these ice tables, they're the same every single time. Okay? So I know this is new, and we're going to practice it again, but it is the same process. All right, so let's solve for this. Okay? So we move him over. So negative x is equal to negative 0.00240. Then change the signs to get positive 0.00240. All right, so now I want to know what these numbers are. I want to know what is the equilibrium for H2, what is the equilibrium for I2, which is this number, and then what is the equilibrium for HI. Okay, so I need to plug in this x to every one. Now you don't have to do this one because we already know the answer. All right, so for H2 equilibrium, we said it was 0.01 minus x. So 0.01 minus x. So if I know what x is, this is 0.01 minus 0.00240. So this guy is going to be 0.00760 molar. So that's my H2s. I2, well, you already know. That's how we figured out x. So we just rewrite that number. HI's equilibrium. That was 2x. So that's 2 times the number we found for x, which was 0.00240. So HI's value is 0.00480. All right, now I have the equilibriums for all of my reactants and products. So go back to the KC that we wrote. I'm just copying over this guy right here. So our KC was HI squared divided by H2 times I2. Now we have the equilibrium. Do we have HI's equilibrium? That's this guy right here. H2's equilibrium, yep. I2's equilibrium, yep. Plug it all in. 0.00480 squared. H2, I2. All right, let's do some math. That top number comes out to be 2.304 times 10 to the negative 5. The bottom, the 0.076 times the 0.0056 is 4.256 times 10 to the negative 5. Top divided by bottom gives me 0.541. And that's my KC. All right, we're gonna practice some more of these, but I want you to start getting used to seeing an ice table, okay? An ice table is gonna be really important because we can only plug into my KC right here, equilibrium concentrations. If it's not an equilibrium, you can't plug it in. All right, make sure you're staying up on your homework, make sure you're staying up on your other classes, and stay healthy.